So we're going to finish 9.5. This was on the binomial theorem. It had a bunch of different ways of expanding binomials. So if you have a plus b or x times y or x plus y or something like that, or an expression here plus or minus an expression here, you can raise it to a power using either the binomial formula with the combination formula, or you can use Pascal's triangle. So we did the combinations for this one right here. So if I cleaned this up and made this look nice, this would be x to the fifth. This is going to be 10x to the fourth. This is going to be 40x to the third. This is going to be 80x to the second. And then this is going to be 80x. And then this is going to be plus 32. Did I do that right? All the right numbers there? Okay, now, what normally happens with these numbers, like on Pascal's triangle, like we've got up above, the coefficients get bigger and then they get smaller. Does anybody know when we have a list that's the same forward and backward, or at least like the center, it looks the same, it's symmetric on both sides? Anybody know what that is? It's called a palindrome. Anybody ever heard of a palindrome? Hope has. Okay, let's see, there's a company on TV and on the radio. They're a carpet cleaning company, and their name is Zero Res. Okay, Zero Res is a palindrome. Okay, it's the same forward as it is backwards, and if you look at this right here, right down the middle, it looks the same on either side. Okay, so that's a palindrome. Okay, but these numbers don't work that way. Okay, these numbers, they get bigger for a minute, they stay the same, and then they get smaller. Okay, and there are some that we'll come across that will just continue to get bigger and bigger and bigger and bigger. Okay, why don't these numbers follow the same type of pattern as the Pascal's triangle? What makes this different? Why does this end up a 32? Because of that extra 2 right here. Okay, you could think of it as a coefficient. If it's got an extra coefficient in there, it's going to change both the powers of x and it's going to change the powers of that number on the end or that expression on the end. And the reason this isn't a 5 anymore is because this had a 2 to the fourth on the end of it. Okay, so anytime you've got coefficients here, it's going to change what those coefficients are up here. So for example, notice the coefficient on both of these was 1. That's why the numbers that are in this list right here are exactly the same as the number in Pascal's triangle. If I've got a coefficient on either one of those other than 1, we're going to get numbers for coefficients that are different than what appear in Pascal's triangle. Okay? Any questions about that? Okay. All right. So let's flip the page over and let's take a look at this one right here. We can make this a little bit easier if we've got Pascal's triangle, which we have off to the side over here. And if you'll remember, this is for 0 to the first power, to the second power, to the third power, to the fourth power, to the fifth power. I did the one for the sixth power. Okay, so we want to expand 2y minus 3 raised to the fourth power. Okay, so here's what we do. Remember, the powers from the first one are going to start off at that, and then they're going to get smaller. And the powers for the second one are going to start off at 0, and they're going to get bigger until they get to be that right there. Okay? So this is to the fourth power. So what row do I look on here in order to figure out what the coefficients are? Okay, I look at row 4, okay, or that is actually the 1, 2, 3, 4. It's actually the fifth row that I look at, right? Okay, so here's what I'm going to do. We're going to write it down this way. That coefficient from this row right here, and let me highlight this so we know what we're looking at. Okay, we're going to be looking at those numbers right there. And remember, because it's the fourth power, I'm going to have 1, 2, 3, 4. I'm going to have 5 terms in my final answer. So here's what we get. I'm going to take the 2y, and I'm going to raise that to the fourth. I'm going to take the negative 3 and raise that to the 0. So I really don't have to write that if I don't want to. And what's the coefficient that I should have sitting out front? What's the first one in this row right here? A 1. Okay? All right, the next one. What's the coefficient I should have sitting out front? a 4. Okay? And then I'm going to have 2y raised to the third, and I'm going to have negative 3 raised to the first. Okay? These exponents are always going to add up to be 4, and the first one's going to go down while the second one goes up. Okay, the next one, this is going to be a 6 for a coefficient, at least to start with, a 2y squared, and a negative 3 squared also. Next one's a 4, 2y to the first, negative 3 to the third, and then the last one has a 1. Okay, if I wanted to write 2y to the 0, I could, and then it's going to be negative 3 raised to the fourth. Is that right? Okay, got a little bunched for space there, but here we go. Okay, so this is going to end up being a 1, and then I've got 2y to the fourth. So think about what 2y to the fourth would be. What would that be? 16y to the fourth, right? So we should see these powers start out for y really big, and then they're going to gradually get smaller. Okay, for this next one, let's stop and think here. This is going to be 8y to the third. I've got a 4 and I've got a negative 3. I've got one negative 3. So you might want to break out your calculator for this if you need it. Negative 12 times 8. Coefficient's definitely going to be negative. What is it? Negative 96. Y to the third. And then we just keep going down the line. So this is going to be 4y squared. I've still got the 6, and I've got a 9 there. So these are getting a little bit bigger. I've got 54 times 4. They are all positive, so this is going to be positive. 216. Y to the second. Next one, I've got the 4, I've got the 2y, and I've got a negative 27. So I've got an 8 times a negative 27. An 8 times a negative 27. 216, and it is negative. And what's the last one? A 1, that's a 1, and then we've got negative 3 raised to the fourth, so that's going to be a positive 81. Okay. Now, if we compare these two methods, let me make this smaller for just a second. If we compare these two methods, now realize that I wrote all of these down for you. There's still a fair amount of writing. Which one's easier? You like using the triangle or using the combination formula, the 5 choose 0, 5 choose 1, and so forth? Triangle's a little bit easier. Does anybody see any disadvantages to the triangle? Well, you'd have to memorize it, okay, which wouldn't be too bad to a certain extent. Or we've got this down to the 6th row, so this would work for 6th powers. Nathan?
You would have to know the numbers before it in order to determine which numbers you're going to be using.
Like these numbers here or these numbers here?
On Pascal's triangle, in order to figure out like the 4th row, you have to know the 3rd row.
Oh, exactly. Okay, so in order to know so we couldn't make this, this is going to be actually the 8th row coming up next. We couldn't make the 8th row without knowing the 7th row and so forth. So if I were going to do something that was raised to the 12th power, I would need to build Pascal's triangle all the way down to the 13th row. Does that make sense? That doesn't work very well, okay? So Pascal's triangle works really well down to about here. I mean, it's pretty quick to write this down. It doesn't take much time at all. You'd have to be careful, but it doesn't take a whole lot of time in order to get that. Okay? Going much further than that, think about how many numbers you have to write down. Even if we were to go down to like the 11th row or something like that, so we could raise something to the 10th power, that'd be a pain. And you make one mistake, you're going to end up writing down 100 numbers just so you can get started. Okay? So there are some advantages and disadvantages to both. Luckily, there aren't very many problems where you have to expand the entire thing. Some of the questions are phrased like this. It says, find the indicated term of the expansion. So for this expansion right here, find the third term. Now, I'm going to use the formula for this because I think that's going to be a little bit easier. And let me show you how we're going to do this. Okay? If I want to find the x cubed term, that would have had to come from having 3x, that first one, raised to the third. Am I right about that? That's the only way you're going to produce an x cubed. Good? That means I'm going to have a negative 2. And what's it going to be raised to? It's going to be raised to the fourth. Now, this power right here, if you remember, it is always up here in the combination formula. And my question for you is, what goes right here? It's either a 3 or a 4. How many say 3? How many say 4? Okay, we're about half and half. Let's go back to the formula and let's figure this out. Okay, here's where it is, and you can see what happens right here. It's always n choose whatever the power is on this second one right here. So the reason this is a 3 on the other one is because we subtracted 4 from the 7. Everybody see that? So the easy way to find it is figure out what the power is on this one. That one's going to be exactly the same. Let me show you what I'm after right here. The reason this is a 3 is because that's 7 minus 4. You put a 4 here, you do n minus 4 here, and you do to the fourth power right here. Okay. Are there any questions? That's the setup, and then all we need to do is figure this out. This would be 7 factorial, 4 factorial, 3 factorial. This is going to be 27x to the third, and this is going to be 16. And what I need to do is I need to figure this out right here. Okay, and again, I wrote it this way. I would highly encourage you doing this. We know there's a 3 and a 4 on the bottom factorial, so I do 7, 6, 5, 4 factorial, 4 factorial, 3 factorial. Cancel those off. 3 factorial, isn't that 3 times 2, which is 6? So here's what I've got. 35, 27x to the third, times 16. So a pretty big number. Go ahead and plug that into your calculator. What is 35 times 27 times 16? What is it? Anybody got it? 15,000? 15,118. What? 120. Good? Okay, stop and look at that because you've got several problems. Those should be relatively easy. Are there any questions on that? Do you want me to run through again how we got this? Okay, if you get this, then let's take a look at this one right here. This one is a little bit different, but it's structured the same way. So we want to find A, and I think I may have written yours a little bit differently. I changed the verbiage for this when I was reading through it again. Find A. In other words, find the coefficient to the x to the 8th term if we're dealing with x squared minus 2 raised to the 12th. So let's stop and think about this. How am I going to make an x to the 8th term using this right here? I'm going to have to take x squared, and do what with it? Raise it to the 4th. Isn't that right? The way I make an x to the 8th is I take an x squared and I raise it to the 4th. If that's the case, I've taken care of the power for the first one. This other one's going to be a negative 2 raised to the... What do these powers always add up to? Whatever the power is right here. They add up to whatever the n is, whatever the exponent is. So this would be an 8. What goes on the top here in this combination formula? A 12, and what goes on the bottom? An 8. Okay? And then, can you finish that one off? Go ahead and finish it off. Get your number answer. Get the coefficient. So you know what the coefficient is on x to the 8th. Check with your neighbor once you've got it done. Because we knew we needed to make an x to the 8th. So the way we're going to make an x to the 8th, we're using whatever this is, that gets used here, raised to a power. Whatever this is, that gets used here, raised to a power. These always have to add up to 12. So if I want to make an x to the 8th, I'd only have to take x squared and raise it to the 4th power. That means the other 8 powers are over here. Does that make sense? Okay, remember when you're writing down these combination formulas, if you're going to figure them out by hand, the top is always going to be a bigger factorial. So I would figure out what factorials you're going to have on the bottom. You're going to have an 8 factorial and a 4 factorial because we're choosing 8 of them. And then I would write this one down until you get to the biggest one down here that you're going to be able to cancel with. So I can cancel the 2 of those. And then I can stop and think about what I've got here. I've got a 4, a 3, and a 2. So I can cancel the 4 with the 3. That'll take care of the 12. And I can cancel the 2 with the 10. That'll make that a 5. So I've got an 11, a 5, a 9, an x to the 8th, and a 256. So when I do 11 times 5 times 9 times 256, I get this big ugly number that is the coefficient on x to the 8th, which is what we're looking for. And what is that number? 751? No, it's got to be way bigger than that. 126,720? We good there? Okay. Any questions? Okay, if you are not sure how to do either one of these, please ask a question now. Is there something that doesn't make sense? Somebody asked, well, why do we raise this one to the 4th power? Why not to the 8th power? Okay, well, if I need an x to the 8th, it's going to come from taking x squared and raising it to a power. So if I take x squared, if I raised it to the 8th, that would be to the 16th. I only want x to the 8th. So I raise it to the 4th. That means the other 8 powers have to be applied to this other piece of that binomial. Does that make sense? Okay, any questions? Okay, let's take a look at this next one. This one's a little bit easier. This one says expand radical x plus 2, and we only want to raise it to the 4th power. Now, we need to expand the whole thing, so would it be worth our time to figure out or write down what Pascal's triangle is? Okay, you have a cheat sheet up there, don't you? We're raising this to the 4th power, so it's that one right there. So let's see, once I see it, I can keep track of 1, 4, 6, 4, and 1, right? So here's what we're going to do. Okay, I'm going to give you about a 10-second head start on each one of these terms. I want you to write down what the first term, how we would construct the first term. We'll simplify it in a minute. First one would be a 1 for the coefficient, square root of x raised to the fourth, and technically a positive 2 to the 0. Next one. Positive 4, radical x to the third, 2 to the first. Got a 6, square root x to the second, 2 to the second. Going back down that palindrome there, 4, square root x to the first, 2 to the third. Finish off with technically a 1, technically a square root x to the 0, and a 2 to the fourth. Okay, this would be the structure using the coefficients that come from Pascal's triangle. Now we run through and we write them down as simply as we possibly can. So the question is, and don't say anything out loud, what is the simplest way to write the square root of x raised to the fourth? Who can tell us what the answer is and why that's the answer? Square root of x raised to the fourth. It's a nice answer. A couple different ways you could explain it. Putin?
It's x squared.
It is x squared. Why is it x squared?
Because
A radical times a radical cancels out. And how many of these radicals do we have? 4 of them. So I have radical x times radical x. Does everybody agree that would be an x? And I have radical x times radical x. That's another x. So I have an x from this one, an x from that one. So I have 2 x's multiplied together. So that would be x squared. Good? Okay. Anybody think of another way to do it? Sven?
X to the 1/2 and x to the fourth.
So that would be x to the 1/2 raised to the fourth. If I have a power to a power, what do I do with the exponents? Multiply them together. What's half of 4? 2. So that's why it's x squared. Anybody think of another way? Yeah.
Well, because radical x squared cancels out the radical, and then we have -1 2 left over.
Okay, so we could, let's see. So say that again.
So like, if you have like radical x squared, that cancels out the like the square on the outside of the radical.
Like
Yeah,
that?
something like that, yeah.
Okay. Or we could do radical x to the fourth. We could put it all underneath. How many pairs of x's do we have? We have 2 pairs of x's, so there'd be 2 on the outside. Bunch of different ways to think of that, but that's the answer. Any questions there? Okay. I got a 2. I got a 4. So that gives me an 8. What's the easiest way to write square root of x cubed? It does have a radical x in it. Pairs of x's. I only have 1 pair and one's left on the inside, so x radical x. Got a 6. Got a 4. So this is going to be 24. X. Got a 4, got an 8, and that's still just a radical x, so that's going to be 32 radical x. And what do I have here? Just a 16. There we go. Okay, now what's interesting about this is still in descending order. This is x to the second. This is x to the 3/2, x to the 1.5. This is x to the first. This is x to the 1/2, and that's x to the 0. Nice descending pattern, just like you're always going to see with these. Okay, any questions? Okay, got 2 more we're going to look at. Here's problem number 5, or example number 5. It says, find the 6th term in a minus b raised to the 8th. The 6th term. So you got to stop and think about this for just a second. The 6th term. How many terms are there going to be altogether? 9. There are 9 terms altogether. So we got to think for just a second. If I were finding the first one, it would be 8, choose 0, a to the 8 minus 0, right? Minus 2b to the 0. That's the first one. Here's the second one. What goes here? A 1. A to the 7th, 8 minus 1. And then this would be minus 2b to the 1st, right? That's the second one. Okay, now stop and think about this. We're talking about pattern spotting here. We've been doing this with arithmetic and geometric sequences and series. Same thing with other ones that are linear or quadratic in nature. So if I take a look at this one right here, what's the pattern between the way I place these numbers in here and the term we're on? For the first term, that's an 8, that's an 8. For the second term, that's an 8, that's an 8. For the first one, a 0 here, a 0 here, a 0 here. For the second one, what goes here? A 1, and a 1. So if I was on the 6th term, right? A to the 3rd, right? Because it would be 8 minus 5. Negative 2b raised to the 5th. So this is what I want to figure out. That's going to be the 6th term, okay? Easy problem once we figure out what the code is. The code is you got to figure out what the structure of this problem is. So again, this is going to be 5 factorial and 3 factorial. So I'm going to write 8, 7, 6, and then 5 factorial. I'm going to write a to the 3rd, and this is going to be negative 32b squared. And then all I've got to do is figure out what I've got here. I can cancel the factorial here. 3 factorial is 3 times 2 times 1, so that's a 6, so I can cancel that off. So I've got 56 times a to the 3rd times negative 32b squared. So I have an a to the 3rd b squared. Oh, b to the 5th, sorry. I took that off there, didn't I? There we go. And if I multiply those numbers together, I get negative, what do I get here? Negative 1600 or something? 1792? Negative 1792. Now, what part of that should be a little bit comforting in the fact that you can look at that and you can know, gosh, at least we did part of it right. What's that? But the exponents. What should the exponents add up to if these were both raised to the 1st power and the whole thing's raised to the 8th? Shouldn't they add up to 8? We've got them adding up to 8. And if you think about the way these count down, there are 9 terms altogether. We've got the 6th one. The 6th one should count with a 3 because the 7th, should be an 8 to the 3rd because the 7th one's going to be to the 2nd. The 8th one's going to be to the 1st, and the 9th one's going to be to the 0 power. So isn't that going to be 3rd from the end, or the 6th one in the list of 9? Does that make sense? Okay. Kind of a relatively easy problem, but kind of in code. Now, we're going to do problem number 52. 52 is either on your assignment or it's very much like one on your assignment. This type of problem comes up a lot in calculus, and if you know the binomial theorem, you can just make your life a little bit easier. Okay? So, here is the function. and here is the expression that we want to write down. So I want to do f of x plus h minus f of x all over h. So the first thing I want to do is I want to figure out what is f of x. That's the easiest thing to figure out here. Isn't it on your paper? X to the fourth. The next thing is, what is f of x plus h? That would be x plus h raised to the fourth. Why would this problem be in the section on the binomial theorem? That's a binomial, and we're raising it to the fourth. So we can come back up here. If we're raising things to the fourth power, again, we're looking at this list right here. And here are the numbers that we'd have to write down. This is going to be x to the fourth plus 4x to the third h to the first plus 6 x to the second. Again, notice how the powers of x are going down, the powers of h are going up, so this should be h to the second plus, what's the next list on that Pascal's triangle? 4 xh cubed, and what do we end with? H to the fourth. Okay, technically we had an h to the 0, to the first, to the second, to the third, to the fourth. X to the fourth, to the third, to the second, to the first, technically to the 0 power, so that's that one. Okay, this is all f of x plus h. Minus, what is f of x? X to the fourth. All over h. Now, your job to finish this problem off is to simplify that. So take a good look at it. You haven't done something like this before, but I think you can figure this out. Look at it for a minute. I'm going to give you a couple minutes. If you think you've got it right, pop your hand up. In a few minutes, I'm going to have you check with your neighbor and see if you've got it. This looks awful. Look at how many terms there are there, and we're supposed to simplify this. It's a fraction. Cameron thinks he's got it. Is it pretty easy? Jordan thinks he's got it. Nathan? Lynn's got it. The Supreme Commander has it. If you had to describe in one short sentence what to do, or one short phrase, couple of words, what do you do? Okay, simplify. That's a little too broad. Yeah. Okay, put each term over h separately. Okay, that will work. We can do that in just a second. What else? Cameron? Collect like terms, right? Since there's only one term here, I don't really need the parentheses, and there's an x to the fourth, and there's an x to the fourth. Rather than rewriting this completely separately, what do we notice about all the terms that are left? They all have h's. So if I take out an h, wouldn't I be able to cancel that with the h on the bottom? So let's just write down what we've got. We'd have a 4x to the third. We'd have a 6x squared. We'd have a 4x. And what would I have on the end there? I'd have, let's see, h to the third. Oops, I didn't write, let's see. That should be an h squared, and then an h to the third. There we go. Okay? All right. Any questions? That is one tiny step away from solving a calculus problem. One tiny step. Okay? The only thing we do in calculus to finish this off is we put this little word, stands for limit, and this means as h goes to 0. So what would happen to this if h turned into a 0? That would turn into 0, that would turn into 0, that would turn into 0. Does that one have an h in it? So does it change at all? Nope. So if we took the limit as h approaches 0, it would turn into 4x cubed. Okay? And that's something called a derivative, and we do that for about 2 months in calculus. Okay. All right. Any questions? Okay, you got a couple minutes to get started on the assignment. Let's see. Tomorrow is a review. I'll have the review posted by this afternoon, and then we can work on that tomorrow, and then the test is Thursday. Okay?